So today we are going to look at 5.2, evaluating trig ratios for special angles. So the most important thing about this chapter is that you have to memorize two particular triangles because in this chapter you are expected to not use a calculator in determining angles or the ratios of these angles, and they have to be exact. So the first triangle that you need to memorize is called a 45-45-90. Basically, it's just the regular isosceles triangle with a right angle. So if I have this triangle that's clearly an isosceles because two sides are equal, I'm going to allocate these two equal sides to have one because one is the easiest number that you can think of, that's easiest to work with. And if I'm using a right triangle, I know that using the Pythagorean theorem, the hypotenuse is just equal to c squared equal to 1 squared plus 1 squared. So 1 squared plus 1 squared is equal to 2, right? Then I can square root both sides, and c is equal to root 2. So after all this work, I know that this third side is going to be root 2. And because this is like an isosceles right triangle, we also know that the two angles here, they have to be 45 degrees. Okay, so that's the first triangle that you have to memorize. The second one that you need to memorize is this triangle 2, which is called the 30-60-90 triangle, because that's pretty much the angles of this thing. So we'll start with the easier part, which is to label the angle. So this is obviously the 30 degrees, because the 30 degrees is noticeably the smaller angle, and 60 degrees is the larger one, and the 90 degrees is obviously the one marked by the square. Now, how do I remember the proportions of this particular triangle is that we know that the ratio of the base to the hypotenuse, well, that is 1 to 2, right? So that's very important because when you label this, we know that the base, well, let's say if it's 1, then the hypotenuse is 2. So with those dimensions, we can now figure out the third side by taking, the Pythagorean theorem, but calculating the leg for it. So that's c squared equal to a squared plus b squared. We're going to look for the leg. So that means my c is the 2, my a is the 1, and b is just what I'm looking for. So this is 4 equaling to 1 plus b squared, which equals to 3 equals to b squared. And rooting both sides, I know that b is equal to root 3. Okay, so after all this is done, I know that the third side is root 3. Now, how is this going to be useful to me, this particular triangle? Is because using this triangle gives me exact ratio of the dimension. So if, let's say, I was looking at my sine ratio, I know that sine is opposite over hypotenuse. I can just reference my sine of 30 degrees. So where's the 30 degrees? 30 degrees is this angle right here. And if I want to figure out the opposite over hypotenuse ratio is from 30, I know that it's going to be 1, which is my opposite, over my hypotenuse, which is 2. So that will give me 1 over 2. Okay. I'm going to continue using the sine ratio now that I'm thinking opposite over hypotenuse on the 45 degrees. So now I have two choices of 45. You can use either one, it doesn't matter. And I am going to figure out what the opposite over hypotenuse is. So opposite is 1, the hypotenuse is root 2, so that's 1 over root 2. And finally, my 60-degree angle, from the second triangle, I know that my opposite is root 3, and my hypotenuse is 2. So all I'm doing is then filling out this chart like that. Okay. Now, using cosine and tan, I mean, the technique is pretty much the same thing. We know that cos is adjacent over hypotenuse and tan is opposite over adjacent. Okay, so cos theta of 30 using the 30-degree angle is adjacent over hypotenuse, so that's root 3 over 2. And the 45 degrees, so adjacent over hypotenuse is 1 over root 2. And finally, the 60 degrees, adjacent from that is 1, and hypotenuse is 2, so that's 1 over 2. Okay, and then tan 30, opposite, which is the 1, over adjacent, which is root 3. Tan of 45, well, opposite is 1, adjacent is 1, so that means 1 over 1 gives me 1. And 60 degrees of tan is opposite, which is root 3. Adjacent is 1, so root 3 over 1 gives me just root 3. Okay, now having this filled out halfway is already good enough, because for my other ratios, my cosecant, right, is 1 over sine. I know that secant is 1 over cos, and I know that my cotangent is 1 over tan. Okay, so all I'm really doing when I put these different sine ratios into my secondary trig ratios is I'm just really flipping them, right? So if I put, let's say, 1 over 2 underneath the 1, so 1 over a half, that will give me 2. So all I'm really doing is reciprocating its corresponding ratio. I'm looking at the sine and I'm reciprocating it. For the secant, I'm looking at my cos column and I'm just reciprocating that. And then for my cotangent, I'm looking at my tan ratio and I'm reciprocating those. Okay, so that's how you fill out this chart. Now this chart is super handy because later on you are going to use it in questions that will ask you to determine the exact value of each expression in trig with trig ratio. So for example, in part A where it says sine of 45, well, what's sine of 45? Sine of 45, I can just reference my chart and I know that that's 1 over root 2. Cos of 45 is also 1 over root 2. And sine 30 is 1 over 2. Sine of 60 is root 3 over 2. So all of this I got from the summary chart. And now what is left to do is to evaluate it and to simplify it to lowest, nicest term. So all I'm doing is multiplying them out. So that's root 3 over 4. And because I have now to add the fractions, it's always nice to put them together. So that means I need a common denominator of 4, which means this 1 over 2 becomes 2 over 4, and root 3 just stays because its denominator is already 4. And that's my final answer. I cannot simplify that anymore, and it's exact. Okay, now in part B, you may not be familiar with this, but when you see that a trig ratio has an exponent of 2, like in the middle, what this really means is that you're taking 10 of 60 and you're just squaring it. That's really what it means. It's just that, the square, that exponent has been moved to be in the middle. Okay, so not to worry. We know that this means tan 60 square for people that need to see it like that. Okay, you can always rewrite it so that it's easier on your eyes. And tan 60 is going to give me root 3, so I can square that. And sine 45 is 1 over root 2, so that is also squared. Okay, so when I square roots, I know that it exactly what's inside the the radicand, and 1 over root 2 is going to be 1 over 2. Okay, so that means common denominator, I got 6 minus 1, so that is 5 over 2. Now, with example 2, the opposite is happening. So now they're giving you a ratio and you have to determine the angle. So let's pretend we don't have a calculator and we want to know what that angle is. And so we know that the angle is between 0 to 90 degrees. And so what we can do is, well, let's look at our chart again and figure out which angle corresponds to a ratio of 1 over 2. And that is obviously the 30 degrees, as you can see here, that corresponds to 30. So that means, knowing that, I know that theta then is equal to 30 degrees because I got it from the chart, which comes from the memorization of the two triangles. Next, you can see that the root 2 is in front of the cos theta. And so to rewrite it, what we have to do is basically divide both sides by root 2. And doing so means that you have now cos theta equaling to 1 over root 2. Okay? So which angle do you get with a ratio of 1 over root 2? Let's look at our chart again. And we can see quite clearly that cos theta with a ratio of 1 over root 2 is 45. So that means my angle then is equal to 45 degrees. Okay, not too difficult. Example 3 is now what I would say it's a little more difficult, but not to worry. What we have is that we're looking for the exact area of this triangle. So remember, of area of triangle, let's refresh what we need to solve this question with is that it's base times height divided by 2. Okay, so what we really need is the length of the base, and we also need the length of the height, and then multiply that to divide by 2. Now, we need to do this in steps in order to get this. So I think the first one I'm going to start doing is actually the h. Yeah, so I'm going to look for h first, the height. So I'm going to be very organized and remember that cos theta equals to root 3 over 2. Now, what's really interesting about this triangle in TRS is that this hypotenuse is equal to 13, and we know that cos theta, or the cos ratio, is adjacent over hypotenuse. So that what they're saying is that the adjacent to the hypotenuse is root 3 over 2, but because in this particular triangle your hypotenuse is 13, well, I have to then figure out then what is h by using this ratio. So h was my adjacent by looking from beta, and having the setup, I can then cross multiply this. So 2 times h is 2h, and then you got 13 times root 3, and we will keep it like that. And then divide it by 2 because we want h and not 2h. Okay, I now have found my h, the exact value for h. So after this, I think what we can do is we can continue using our ratios to determine what the other, to figure out the base, because the base is pretty much composed of two parts, B1, which is where SR is, and B2, that is RQ. If we find B1 and B2, that means we can add them together to get our base length. So if you remember, where does this cos beta root 3 over 2, we can go back to our chart for reference. And we know that cos root 3 with a ratio of root 3 over 2 pretty much tells you that the angle is 30 degrees. So I know that this triangle in particular, this one, has to be a 30-degree angle. Okay, so if this is 30 and there's a right triangle there, that means this has to be 60. So that looks very familiar. That looks like triangle 2. And if this angle R is right triangle, that means so is its opposite side, because it shares the same supplementary angle. And that angle QPR, if one side is 45, one angle is 90 degrees, that means the other has to be 45 degrees. So that this PQR triangle is an isosceles. Okay, so what they've pretty much done in this question is put two triangles that you should memorize, stack them together, and now you have to use them to determine those lengths. So what I'm going to do is, to get B1, I'm going to use the same angle, so beta, which is 30 degrees. And this time, instead of using the cos ratio, I want to figure out, I'm going to use the opposite hypotenuse ratio because I want to figure out what B1 is. So that would be the sine ratio. So I'm going to use the sine beta, and I'm going to make a note that it is equal to opposite over hypotenuse. Okay, so sine 30, I'm going to put 30 here. Sine 30 is, on my chart, sine 30 is 1 over 2, right? So that means I'm going to put 1 over 2 here, because I know they're equal to each other. And that in this particular triangle, using similar triangles and proportions, opposite is B1, and my hypotenuse is 13. So cross multiplying all that gives me 2b1 equals to 13. And then I can divide it by 2. So b1 is 13 over 2. Okay. B2 we're going to look for. And we know, actually, we don't really need to do much work because, look, if PQR is an isosceles, right? We have H already, which we already solved. Then that means H and B2 must equate with each other because of isosceles triangle, right? So that means so B2 is the same as 13 root 3 over 2. So to get B in length, I'm going to add them together. I'm going to combine them. So that means 13 over 2 plus 13 root 3 over 2 will give me, because they have a common denominator, that is wonderful, will give me 13 plus 13 root 3 over 2. Okay, so I have the base, I have a height, I have the base, which is right here. Now I can use my area triangle formula. So area is equal to 13 plus 13 root 3 over 2 times the height, which is 13 root 3 over 2. And then after having to multiply base times height, I'm also going to divide it by 2 or multiply by a half. Okay, so if I don't want to use too many fraction over fraction, I can just rewrite it like that. So 2 times 2 times 2 is 8. And finally, I can rewrite all of this as 13 plus 13 root 3 times 13 root 3. And at this point, what I can do is also expand it, because I don't like having so many brackets. I'm going to take this 13 root 3 and multiply to everything inside here. So that will be 169 root 3 plus 169. Now root 3 times root 3 will give me just regular 3. So nothing exciting about that, but now at least my answer looks a lot nicer. Okay, and I am definitely not using a calculator right now. 169 times 3 is 507. Okay, so finally, I have, this is my final area. I'm not going to say it, it's a mouthful, but it's exact and it's perfect. Okay, so all of this is necessary from the chart, which comes from the memorization of these two beautiful triangles. The last question that we're going to look at is how to solve for more complicated things. So basically, this example 4 is really testing to see if you understand, what cosecant mean. What does secant mean? Do you understand these ratios? So you might have tried to figure out using a calculator what's like try to find a secant button. It doesn't exist. And so for you to work with secant is you have to understand that secant is the same as 1 over cos beta. Okay? And if that equals to 4, that means this 1 over cos beta equals to 4. Okay? How do I then kind of release this cos beta? Well, I can write this 4 as 4 over 1. And then I am just going to flip both sides. So then cos beta is actually equal to 4. Okay? So let's try to understand what this really means. The best way to do this is I like to draw a picture and understand that, well, cos beta is also adjacent over hypotenuse. Okay, so I need to draw a triangle, something like this. Okay, my hypotenuse is going to, I forgot to flip it. Okay, so this should be 1 over 4. My hypotenuse should be 4. My adjacent should be 1. So if I'm looking, let's say this is my angle here, then this part is my adjacent, right? And so maybe we would need to determine what that third side is using Pythagorean theorem. So we know that 4 squared is equal to 1 squared plus b squared. So 16 equals to 1 plus b squared. We got, so this is going to be 15 g equals b squared, and we're going to square root both sides. So now I know that b is equal to 15. Okay, so with that all done and nicely labeled, we can proceed with answering the rest of this question, because here we can say that, well, tan beta is opposite over adjacent. So from the beta point angle as my reference, I'm going to say that my opposite is root 15 and my adjacent is 1. So that is equal to root 15. Cosecant beta is 1 over sine, or like the reciprocal of sine ratio, so that will be hypotenuse over opposite, right? So that means from the angle again of beta, the hypotenuse is 4 at the top, and the opposite is root 15. Finally, cos square beta. Well, we already know that because we found it at the beginning of our question. Okay, so now that I have every element in this complicated equation, I can pretty much rewrite all this in terms of exact value. So tan beta is root 15. Cosecant beta is 4 times root 15. And cos square beta, so that means 1 over 4 squared. Right? So now I'm just going to multiply them together and determine what each thing is. So because you got root 15 and root 15, so these cancel out, which is very nice. So that gives me 4 over 1, which equals 4, minus 1 over 4 squared, so that is 1 over 16. And finally, when I am evaluating this together, I know that, well, 16 times 4 is 64, I think. Yeah, it is correct. I can minus 1, and so the exact value of this ratio is 63 over 16. Okay? So the most important thing in this chapter is really to memorize these two triangles. You need to know them so that you can develop this chart, which will give you exact values, so that you can answer all these questions. So it's a good idea to maybe draw it at the top of your tests or your quiz when you first get it, so that you can keep on using it as you do these questions. Okay? That's it. Have a good day.